so exciting. I've never seen software that took quantitative EEG measures from a wearable headset and show different brain circuits, specifically like the default mode network, that you could say this is abnormal and we need to do something about it. What did that look like for iMedisync to be able to design the whole software program?
Hey everybody, welcome to Techforpsych. I'm Dr. Cody Rall, your medical doctor confidant. In this video, we're sitting down with Dr. Kang, founder and CEO of iMedisync, a company that is threatening to revolutionize how brain assessments are done at home and in the clinic. Dr. Kang founded this company with software in mind. Their software is really incredible when you look at it, especially for me as a provider, to be able to see how the brain functions through ERPs, quantitative EEG, and to be able to actually see the function of individual brain circuits through EEG technology is very exciting. All these assessments, I think, are a glimpse of what's coming in the very near future for physicians to be able to use to diagnose brain disorders in the clinic moving forward, and that information will trickle down into consumer wearables at home as well. And what actually ended up happening is that Dr. Kang's company came up with the software, and then they realized in order to properly democratize this information, they actually needed to create hardware as well. And they've got this helmet called iSyncWave that uses EEG sensors on the end of brushes that get down below the hair follicle, so it gets good EEG signal. And you can imagine just being able to use this helmet at home, in the clinic, anywhere that you would want to use to assess and get brain data for clients or patients or whoever else would be using this hardware. So I hope you enjoy. Please leave your comments and questions below, and don't forget to subscribe to the channel.
So Dr. Kang, thank you so much for joining us. I'm really excited to talk about the iSyncWave. I know you have been working on it with your team for years. Would you mind introducing yourself and letting us know what your background is?
Oh, yeah. I graduated medical school of Seoul National University in Seoul, and finished family medicine resident training. So basically, I'm a board certified family medicine doctor in Korea. But most specifically speaking about my career identity as a medical doctor, I have pursued integrative medicine, and I'm also a specialist of integrative medicine, especially interested in body, mind, and spirituality. That's the reason why I have pursued some integrative research and approach for relationship between mind and body in many medical disorders, especially some psychiatric or psychological problems.
So tell us about the iSyncWave. How did this get created? Why did you go in the direction of a EEG helmet like this?
So while I pursued some mind-body integrative approaches, so I realized that biosignal processing and brain mapping is a very important research theme to uncover some relationship between some mind and body problems. At first, I started some brain mapping solution software development. And then, so actually our company, iMedicine, is a kind of cloud software and brain mapping analytics company. And after we launched some cloud-based QEEG analytic platform, then I realized that to expand our usage to many clients, then we need some very comfortable and user-friendly EEG acquisition headset. Then for a few years, I have designed and developed some this headset. And then finally, we has been successful in developing this prototype of iSyncWave.
Can you tell us about the decision to go with dry EEG electrodes and how that's factored into accessibility with the helmet?
Yeah, so the EEG is very weak biosignal, just some microvoltage amplitude signals. So it's very hard to get good signal quality with dry electrode. But a dry electrode headset is a kind of dream for many companies. And many companies have launched their own dry electrode headset. But from my point of view, the good signal quality is not fulfilled. The most important thing is to get the good signal quality with dry electrode. Keeping the good contact on scalp is very important because without gel, just dry contact, then if we can't keep the good contact with electrode on scalp, the quality of signal is very fluctuating. It's very important. Mm-hmm. So our headset has dry electrode with some conductive polymer foam coated with AgCl. So basically, our dry electrode is very good. So the unique characteristics of our headset is we divided it some part and module, and each module has gear and spring. So if we put this headset on skull head, then automatically size up while keeping the same ratio between the electrode position. And then, this spring and gear system could keep the international 1020 locations and also tighten and electrode on scalp and then keep the good contact during the acquisitions.
And how is the data transmitted to the cloud for analysis?
Yeah, we developed our own unique application working on a smart device. So this wireless headset could send the signal via BLE to the application, then it's automatically uploaded our cloud system.
Is the data processed at all on the helmet, or is it processed on a tablet or in the cloud?
Systems.
Okay, so it's filtered through Bluetooth.
Yes.
And then taken to the cloud for further analysis.
Right.
Okay. Mm-hmm. And how do you envision this product being used in clinics or with individuals? What was the idea for how people are going to interact with this device?
Yeah, at first in clinics. So I've been developing many QEEG brain mapping and machine learning algorithm for cognitive impairments due to Alzheimer's disease or Parkinson's disease, stroke, or other children's developmental problems. So at first it will be launched in Korea for clinical purpose, but in the future, I envision that this device will open so-called telemental care at home. So that's our some future vision with this device.
Are there any research projects in South Korea happening right now that you could talk about?
Yes. we have collaborated with several research hospitals in Korea, and also now we are planning collaboration research with Israel Hospital also for some depression and dementia disorder. So in Korea, we have developed some machine learning algorithm for dementia and early detection for dementia and Alzheimer's disease, and some QEEG-based discrimination and classification of Parkinson's disease. And so recently we started some QEEG mapping solution for a stroke and post-stroke vascular dementia prediction.
That's
and
amazing.
Also, yes, thank you. And we also are developing some QEEG-based prediction algorithm for coma recovery. For example, after ischemia after cardiac arrest, then many patients fall into the coma state, and some could recover fully, and then another person can't wake up. So it's very important to predict some recovery and prognosis during acute coma state. Then we are actively developing this algorithm, and the accuracy is very promising. So, we have actively collaborated with many hospitals in domestic and international university and hospital, and some dementia, Parkinson's, some depression, children's developmental problem, stroke, and coma, and etc. Theoretically, we could cover almost all mental problems from children to elderlies.
How does a company like iMedisync move towards communicating with the FDA your capabilities and eventually getting approval in Korea and or in America as well?
Yes, our cloud analytic platform, iSyncWave, already cleared the Korean FDA as Class 2 medical device. And also, our machine learning algorithm for early detection of dementia also cleared the medical device as Class 2 medical device in Korean FDA. So we have to move forward to US FDA with another validation clinical trials.
Do you have to get FDA approval for the helmet?
I think so.
Okay.
But
the visuals are so exciting. I've never seen software that took quantitative EEG measures from a wearable headset and show different brain circuits, specifically like the default mode network, that you could say this is abnormal and we need to do something about it. How did you, I can't imagine the amount of research that it took to gather all the information about the different circuits and put it together in a software program. What did that look like for iMedisync to be able to design the whole software program with brain circuitry? So,
recent psychiatry has great discrepancy between neuroscientific knowledge and real diagnostic criteria. So many psychiatric problems is originate from brain dysfunction, but in real clinical situation, psychiatrists just use some interview and questionnaires and some neuropsychiatric battery tests. So I wish to apply this QEEG-based brain mapping and connectivity analysis solution in real clinical situation. And I have gathered lots of healthy person's EEG data from young kids to elderlies, and standardized the QEEG pattern according to the age and sex. And then based on the healthy brains database, then we set some default mode networks with some signal processing such as coherence between two different time series data. This coherence is related, this coherence is some functional relationship and similarity between two different signals, and then we could calculate some functional relationship and connectivity between two different ROI. So that's the basic theory, how we can calculate the brain network, such as default mode network, with our brain analyzing solutions.
It sounds like you collected your own data for the data set, correct, for the Z-scores?
Yes, correct.
And that was done using the iMedisync, iSyncWave, and the software.
Yes.
It's very exciting.
Thank you.
Can you tell us about this LED light feature?
Yes. So there are many different physical stimulation solutions in neuromodulation field. Some magnetic stimulation, some electrical stimulation, ultrasonography, or some this LED. I've been interested in this LED therapy because as integrative medical doctor, so yeah, I think some mitochondria in our animal cell has very similar origin, ancient origin with chlorophyll in plant cells. Their similarity is they love light and they react actively to the light. So our mitochondria and some near-infrared light could penetrate the skull bone and directly stimulate the mitochondria in neuronal cells, and then boost its metabolism, and then restore the energy level of dysfunctional brain cells. So recent neuroscience has uncovered many brain disorder is occurred by some dysfunction of mitochondria in neurons, some aging, degeneration, some ischemic damage. So almost all brain cells damage is started from mitochondrial dysfunction. So if near-infrared light could penetrate and directly stimulate and touch the mitochondria and boost it again, then theoretically it could recover some many brain disorder, such as dementia and Parkinson's. That's the brief theoretical background of LED therapy.
And with the quantitative EEG, you could do very targeted stimulation.
Yes, yeah. The reason why QEEG mapping is important, then we could localize the lesion and how to monitor the change during the therapy sessions.
Well, I'm really excited to see this move forward. What is your vision? I know you said a little bit before, starting with clinics and then potentially going from there, but did you have anything else to offer today about talking about where the company is headed and how you could see the iSyncWave being used in the future in future devices?
Yes. I've experienced lots of very difficult patients during my clinical experience. And unfortunately, many CNS drugs don't work well for many neuropsychiatric problems. So my vision is future mental care is some integrative and non-pharmaceutical and supportive care to recover our own healing power. And it's very important to carefully analyze the brain's dysfunction and mapping, and then individual QEEG-based non-pharmaceutical light therapy or other neurofeedback therapy to recover it. So I hope to develop my company as digital mental care platform company, combined with QEEG AI mapping solution and non-pharmaceutical neuromodulation therapeutics.
Well, I want to thank you for speaking with me today, Dr. Kang. As a psychiatrist that's interested in treating people with non-pharmaceutical methods and also being able to do telemedicine, I'm incredibly excited about what this technology is capable of. So I really appreciate individuals such as yourself that are doing groundbreaking new technology to bring us into the 21st century.
Thank you very much.